This is the carriage lock lever. The purpose of the carriage lock lever is to lock the headstock sliding carriage in its working position. To release the headstock carriage from its working position, pull the carriage lock lever toward the operator side of the machine. Raise both tool head covers. Pull the handwheel knob out. Turn the handwheel clockwise. The headstock will advance toward the operator side of the machine. When the headstock is fully advanced, the cutting tool camshaft section will be coupled to the camshaft end plate. The purpose of the camshaft end plate is to hand crank the tool cams when the headstock is advanced. To hand crank the tool cams, hold in the handwheel knob and turn the handwheel clockwise. The tool cams will rotate. The cutting tools will go through their cutting cycles. To return the headstock to its working position, return the camshaft to camshaft 0. Pull out the handwheel knob, rotate the handwheel counterclockwise. As the headstock returns, position the feed sleeve so that this coupling ring and washer on the end of the feed sleeve go into the opening in the feed coupling nut. Rotate the feed sleeve so that this pin in the coupling nut fits into this notch in the coupling ring. When the sliding headstock carriage is fully returned, push the feed coupling lever toward the back of the machine. Then, push the carriage lock lever toward the back of the machine. Use only enough force to snug down the headstock carriage locking mechanism. Pushing the carriage lock lever too hard can break the locking mechanism. This is the tool head lock lever. The purpose of the tool head lock lever is to hold the rotating tool head. If you are stocking the machine for a new setup, you must now adjust the stock straightener. Close the feed collet to clamp the stock in place. Loosen the 4 stationary adjusting screw lock screws. Turning the adjusting screws clockwise will move the pads toward the stock. Turning the adjusting screws counterclockwise will move the pads away from the stock. Adjust the position of the 4 stationary pads until the stock runs through the center of the pad openings. Tighten all 4 lock screws. This is the overbend pad adjusting screw. The purpose of the overbend pad adjusting screw is to adjust the overbend pad toward or away from the stock. The overbend pad adjusting screw is held in place with this lock nut. Loosen the lock nut. Adjust the overbend pad until the stock runs through the center of it. Then tighten the lock nut. Now you must fine adjust the stationary straightener pads so that the stock is properly supported in the straightener. Remove all tools from the area of the stock straightener. Close the stock straightener cover, start the main motor, then open the stock straightener cover. If the pads or pad holders break, they will fly out of the straightener at very high speeds. This could injure you or another worker. Whenever you must open the stock straightener with the main motor on, do not stand directly in front of the straightener. Inspect the stock in the straightener. There should be no oval rotation of the stock in the straightener. Any oval rotation must be eliminated by adjustment of the straightener pad in the area of the oval rotation. This is the overbend trip arm. The purpose of the overbend trip arm is to control the action of the overbend pad. To determine the direction of the needed adjustment, lift the overbend trip arm. The overbend pad will bend the stock. If the oval rotation seems to move or flutter, the straightener pad in that area must be moved toward the stock. If the oval rotation does not move or flutter, the pad must be moved away from the stock. Stop the main motor. Push the overbend trip arm down. Loosen the adjusting screw lock screw on the pad which needs adjustment. Turn the adjusting screw in the appropriate direction. Tighten the adjusting screw lock screw. Continue to fine adjust the stationary pads until all oval rotation has been eliminated. Up and down movement of the tool cam levers is transmitted through a series of levers to 3 tool sleeves inside the headstock. These are the 3 tool sleeves. Each tool sleeve is controlled by one of the tool cam levers. As the tool cam lever is raised, the tool sleeve is pushed forward. On the end of each tool sleeve are 2 cone segments. Since there are 3 tool sleeves, there is a total of 6 cone segments. The purpose of the cone segments is to control tool travel. The cone segments control tool travel by raising the tool axle levers. To show you a tool axle lever, we will look at a tool head which has been removed from the machine. This is a tool axle lever. On one end of each tool axle lever is a round carbide insert which rests on one of the cone segments. As a cone segment moves forward, it pushes the tool axle lever up. The tool axle lever rotates the tool axle shaft. On the other end of the tool axle shaft is the tool mounting position. A tool cutting operation begins with a rise in the tool cam. As the tool cam follower is raised, the tool cam lever is also raised. This movement is transmitted to the headstock. One of the tool sleeves is pushed forward. This pushes 2 of the cone segments forward. As the cone segments are pushed forward, the tool axle lever is forced upward by the tapered surface of the tool cone segment. This causes the tool axle shaft to rotate. The tool holder rotates as the tool axle shaft rotates. The cutting edge of the tool is forced into the stock. In order to remove, install, and adjust the cutting tools, you must be familiar with the components of tool holders. This is a standard tool holder. These are the tool lock screws. The tool lock screws hold the cutting tool in place. These are the tool holder lock screws. The purpose of the tool holder lock screws is to hold the tool holder in place on the tool head. This is the centering screw on the back of the tool holder. The centering screw moves the tool into or out from the tool holder to adjust the tool centering. During initial tool installment and adjustment, you should advance the headstock. You will not need to advance the headstock when removing tools during a production run. For example, when removing tools to sharpen them.